Welcome to The Explainer. Today, we are digging into one of the biggest challenges of our time, plastic waste. What if, instead of just burying it or remelting it, we could actually turn the clock back on plastic? We're going to break down a technology called pyrolysis that claims it can do just that, and it's all based on a really insightful executive summary on the topic.
Okay, so before we jump into the really cool tech, we've got to get a handle on the problem itself. Because, to really understand why something like pyrolysis is even being considered, we first have to see just how broken our current system is.
For decades, our entire economy has basically treated plastic like a one-way street. It's a simple model, sure, and it was fantastic for production, but as we're all seeing now, it is deeply flawed for the health of our planet.
And this is the system we all know, right? Take, make, dispose. We pull fossil fuels out of the ground, we create all sorts of plastic goods, and then we just throw them away. The huge problem is there really is no away. This whole linear model has slammed into a massive wall. Both physically, we're running out of space, and from a regulatory standpoint.
Now I know what you're thinking. Hey, what about recycling? And that's exactly the right question to ask. But the way we've traditionally done it, what's called mechanical recycling, has a major flaw. It hits something the experts call a fundamental quality wall.
So what exactly is this quality wall? Well, think of it like this. Every single time you melt down a piece of plastic, its molecular chains get shorter. The material just gets weaker. It's kind of like making a photocopy of a photocopy of a photocopy. Each time, you lose a little more quality. On top of that, this process needs really clean, sorted plastics, which means most of the complex packaging our food comes in just gets tossed.
So clearly, that's a dead end. And it means we need a totally new way to think about this. We have to move past just remelting plastic and go way, way deeper, all the way down to the molecular level. It's a real paradigm shift. And this slide really breaks it down for us. Over on the left, you've got mechanical recycling. That's a physical change. But on the right, molecular recycling is a chemical one. So instead of just trying to reshape old, weakened plastic, we're literally unmaking it. We're breaking it down into its original, pristine building blocks so we can create brand new plastic from scratch.
So the key piece of tech that makes all this possible, it's called pyrolysis. To put it simply, you take solid plastic waste, you heat it up, a lot, in a container that has no oxygen, and you actually chemically reverse the refining process. You're turning a solid back into a liquid, specifically a liquid hydrocarbon that we can use all over again.
Okay, but here's a really important question. How do you even track all this stuff? I mean, when this recycled liquid gets mixed into a giant refinery with brand new fossil fuels, you can't physically follow the recycled molecules around. And that's where mass balance accounting comes in. Think of it like a certified bookkeeping method. It lets companies track the volume of recycled material they put in, and then they can assign that recycled content credit to specific products they sell. This is what makes the whole circular economy actually work from a business perspective.
All right, so we're making this oil, but what is it exactly? You hear the term pyrolysis oil thrown around, but it's not just one single thing. It's more like a family of different products. And believe me, understanding the differences is absolutely crucial.
And this table here lays it out perfectly. If you make this oil from biomass like wood, it's acidic and pretty unstable. If you make it from old tires, it's packed with sulfur and other aromatics. But the real sweet spot, the good stuff for making new plastics, comes from plastic waste itself, things like polyethylene and polypropylene. That creates a waxy, low-sulfur oil that's a perfect feedstock. The key takeaway? They are not interchangeable at all.
Now, if you only remember one thing from this entire explainer, please make it this. Raw pyrolysis oil is not a finished product you can just pump into a car. The best way to think about it is as a synthetic crude oil. It's a raw material with enormous potential, but it absolutely has to be refined before it can become something valuable.
And why does it need so much refining? Well, because this synthetic crude is full of contaminants from all the original waste. We're talking chlorine from PVC plastics, sulfur from tires, even tiny bits of metal. In the world of refining, these aren't just impurities. They're quite literally called poisons because they can destroy incredibly expensive equipment and catalysts.
So, if the raw oil is contaminated with all these poisons, how on earth do we actually unlock its value? Well, this is where the real engineering and chemical magic comes into play. It's a whole process called upgrading.
You see, success here isn't just about making the oil. It's about cleaning it. And it's a multi-step journey. You start with basic physical stuff like filtration. Then you might do some mild upgrading to make it stable enough for, say, marine fuel. But if you want to create those really high-value products, like clean road fuels or the feedstock to make new plastics, you need deep refining, using really advanced processes to get all those poisons out.
But here's the thing. Even the most incredible technology is pretty much useless without a solid business plan. The companies that are actually going to win in this space will be the ones that master this strategic triad. First, you have to get your hands on a massive, steady supply of plastic waste. Second, your plant needs to be engineered to be tough enough to handle those contaminants day in and day out. And third, you have to have guaranteed buyers lined up with long-term agreements ready to pay for your final upgraded product.
And all of this brings us to the final, really crucial question. Pyrolysis, as we've seen, is not some simple magic bullet solution. It's a complex industrial process that demands a mastery of supply chains, tough engineering, and smart market strategy. So when you look at all these hurdles, you have to ask, is this technology a true game changer that's going to solve our plastic problem? Or is it just another complicated detour on the long road to a circular economy? That is the multi-billion-dollar question that everyone in this field is trying to answer right now.